Hello, Tom here from Medical Mavericks and welcome to the next experiment which is part of the great Science Share for Schools. And this week we're going to be looking at the pupil reflex. Now if you didn't know, your pupil is the black dot in your eye. So just take a second now, look at your friend next to you and look at each other's eyes lovingly, okay, and see if you can see the black dot in their eye. If you can see that black dot, that is the pupil. And if you didn't know, your pupil is actually a hole that lets light into your eyeball. And we're going to have a look at what happens to your pupil as we shine light across it. So teachers, you will need a couple of little bits of equipment if you've got them. You can use your mobile phone and turn the torch on and kind of use that as your light source. But you can also use a normal torch of some kind as well, or anything that produces a light, okay? A little bit of a disclaimer, you don't want to sit too close, you don't want to shine the light too close to someone's eye. It's not going to hurt anyone's eyes or damage them. It can be a little bit uncomfortable though. So I'll explain how to do this nice and safely in a moment, but when you're shining the light across anyone's face when you're doing this experiment, make sure it's kind of about 30 to 40 centimeters away from their eye, and we're not going to hold the light in place. We're just going to move it across someone's face and eyes. So how do we perform the experiment? Well, there's two parts to this experiment today. The first one is really nice and simple. You need to get your partners sitting face to face. So sit next to your partner, sit face to face, and you get your light source, and all you're going to do, imagine you're my patient now and I'm the kind of physiologist looking at someone's eye. What we're going to do is get my light source, and all I'm going to do is move it across the front of someone's face like this. And you need to watch the black dots in their eye. Just look at the size, have a mental note of the size, keep watching them, and as you shine the light across them, have a look at what happens to them. Now this works best if the room is slightly darkened. So if you've got curtains or blinds, close those. I know it might be kind of quite bright light in a classroom, but turn the lights off, make sure it's a bit darker. If you want to, get your jumpers or your coats and put them over your heads. So you've got like a little cocoon above you so it goes really dark, and then you can really see the effect this light has. But that's just a little bit of an option for you. So that's the first part. Looking at each other, watching the other person's pupils, and we're shining a light across their eyes like this. That's all we're doing. Look at what happens to the pupils at the start, as we pass the light across them, and as the light disappears, okay? Now the second part of this experiment is we're going to look at one eye while shining the light in the other. But the person that's been experimented on has to put their hand in the middle of their head like this. Okay, so you're separating the left and right sides of your face. So imagine I'm now the person being tested here, and you've got the light and you're shining it on me. I would be sitting here with my hand in the middle of my face like this. And all you would do is shine the light across one eye like this, in and out, like that. But you're not going to be looking at this eye. You're going to be looking at the eye that has no light being shone on it. Okay, I'm going to be really clear here. So I'm shining the light on this eye, but I'm looking at this eye. And I want you to have a look at what happens. Look at the size of the pupil. Does it change? And then you can do the opposite. So you can shine the light on this eye, and look what happens to this eye. Really important that you make sure that the eye you're looking at has none of the light reaching it. Really, really important that you do that correctly, okay? So go and have a go at those experiments. Teachers, if you're videoing this or taking any photographs, please tag us in there on Twitter if you're on there. Put the Great Science Share for Schools in there as well as Medical Mavericks. And you can share those pictures and videos with us. If any pupils watching, you've got questions, ask your teacher and ask them to send them in to us. You can send them in via the Great Science Share for Schools website on there as well. Really great to hear some of your questions. Ask them through Twitter as well if you want to. But it's your turn to go and have a go now. Go and have a look at your pupils and see what happens in those two experiments. And then we'll come back, teachers, pause the video, and then we'll come back and explain the science behind what's happening. What did you see? Did you see the pupil change size? Did you see it get smaller as the light was shone on it? You should have, that's what happens. And when the light was moved away, they would have got bigger. And that's because your pupil controls the amount of light going in to our eyeball. So in dark scenarios, they get bigger to let more light in. And in really bright scenarios, they get smaller to let less light in because the light is too bright. Now, what about when you kind of when your partner split their head in half and you shone the light in one eye and then looked at the other? Did you still see the other eye change size even though there was no light being shone on it? It's a really cool bit of physiology, isn't it? Now I'm going to play you a little clip now that explains a little bit more of the science behind this kind of bit of physiology, and then we'll come back and talk about it in a moment. Here's how it works. Both eyes detect the amount of light entering and hitting the retina. This info from both eyes comes into a central point in your brain. This single area then sends signals to both eyes to control the size of the pupil. So it doesn't matter if one or both eyes are stimulated by the light, they'll both react. This is called your pupil reflex. If one pupil doesn't react, that is a sign of a brain injury, making it a really useful tool for assessing head injuries. That's really cool, isn't it? You can see how your left eye is connected to your right eye and your right eye is connected to your left eye, and each eye can control each other's pupil diameter. It's a really awesome bit of physiology, and it's really useful for a medic because we can assess how someone's head, brain and nerves are working if they've got a head injury, because swellings and bleeds on the brain can compress and affect these nerves and stop these reflexes happening properly. So when we look at the eye just with a simple light like this, we can actually see if the brain is functioning properly. And that's the end of this experiment this week for the great Science Share for Schools. Remember, if you've got any pictures or videos, please put them up on Twitter and share them with the great Science Share for Schools, as well as us at Medical Mavericks. And ask any questions through the great Science Share for Schools website. And until next week, we'll see you very soon. Bye.